Hey guys, Chapter 2 Living Planet. We're going to talk about the planets in the solar system quickly, the theory of continental drift, plate tectonics, and you need to be ready for a quiz tomorrow over this stuff. This is mostly science, so we're going to fly through it. Remember, you can pause it and watch it as many times as you can to make sure you get the information. The solar system is made up of the Sun and 8 other planets. You can see them listed. Obviously, Pluto is not one of them anymore. It used to be 9, now it's 8. Obviously, the most important there is Earth. That's where we live, man. If you didn't know that, when you go back to kindergarten, learn that stuff again. The structure of the Earth made up of 3 parts: the core, the mantle, and the crust. 24,000 miles in circumference, so it's a decent-sized planet compared to some, and obviously smaller compared to others. Here's an illustration of the core. You can see the inner, and here's the outer core. So all this is the core, followed by the mantle to the crust on the outer part. And here again, if you cut the piece of pie, a triangle piece of pie, out of Earth, you see the core here, the mantle, and here's a lithosphere up top. Other parts of the biosphere besides the lithosphere, which is the actual crust area of the Earth, the atmospheres, the gases that surround the Earth. It's made up of 4 parts: the troposphere, the stratosphere, mesosphere, and the thermosphere. Obviously, helps in bringing life to our planet. Hydrosphere is the other part. It's the water cycle. You've done it 1,000 times in science. Water going into the atmosphere, into the sky, if you don't know what the atmosphere is, and coming back down to some form of precipitation. Lands on the ground, runs off into other lakes, rivers, other water systems, into our groundwater, and then through evaporation or transpiration, it goes back into the sky. But that's the hydrosphere, the water elements of the Earth. All 3 of those, plus the ecosphere, make up the biosphere. This is the part of the Earth where plants and animals live, including ourselves. So 4 things: hydrosphere, atmosphere, lithosphere, and ecosphere make up the biosphere. You might want to remember that. Theory of continental drift. At one point, all continents were together, and throughout time, we slowly drifted to where we are currently, and probably still moving. But here's an illustration of a dude and his dog. Wrong parts of the land at the wrong time. They're separating, and he wants his little weenie dog to make the jump. Ha ha, very funny. The guy who came up with all this stuff is a guy named Alfred Wegener. He's credited with the origins of the theory of continental drift. Again, another illustration. Here's the man on the left, the woman on the right, and they've been slowly drifting apart for 50 million years. It's kind of a marriage joke, I guess you could say, but again, illustrating the separation between the 2 over time. But you can see here the puzzle piece. If you put all the continents together, you can see through visually that it looks like a puzzle, and you can probably fit these pieces back together. That's one piece of evidence that supports continental drift. Here they are. This is when they were together. They're called Pangea, and they slowly drifted to where they are today. Here's another picture again. Wrong way. Sorry. Pangea breaks apart over time and puts us where we are today. But you can see the puzzle pieces as they come together or drift apart. Evidence to support the puzzle, like I said, they're similar plants and animals with different continents, and the only way they're similar, okay, is if they were together at some point. Evidence of glacial scraping in parts of South America and Africa, and then similar rock edges on continents. And the only way you have some of those things is if they're once together, and as they separated, they left kind of marks on each other when they were separating. Here's India, 71 million years ago on the bottom, and as it slowly, through time, has drifted to the north to where it's located today, in the southern part of Asia. Again, Pangea together. And here's another illustration of it being together up here, and as time progresses, it goes to where it is, where it was 10 million years ago. Plate tectonics, based on continental drift theory. So we're all floating on tops of 13 to 15 plates, moving on top of magma. That's plate tectonics. Here you can see the plates. Here's ours, the North American plate, Eurasian plate, the Indian plate. You can see all these plates right here are responsible for movement, our seismic activity, things like earthquakes, volcanoes, things like that. and we'll get into their movements and what things they cause later on. Here you can see these red dots are all some type of seismic activity, earthquakes, volcanoes. And you can see these blue lines, that's where the plates are coming together. So you can see all this seismic activity occurs on the plate lines. The main features of plate tectonics: Earth's surface is covered by crustal plates. The ocean floors are continually moving. There's convection currents beneath the plates that are moving around. Okay, and the source of heat that drives the currents is radioactive, and it's deep in the Earth's mantle. Ring of fire, here you go. Western part of the United States, down to South America, all the way over into Japan, and other parts of the East. It's the Ring of Fire right here. This is where the majority of seismic activity happens in the world. All on there. Okay. Another illustration of plate movements. Here's our boundaries, plate boundaries. The red is where these plates are colliding together. Convergent is colliding. Divergent, the blue, means they're working away from each other. And then the yellow, transforming, which means they're side by side and they're moving side by side. Okay. Here's a picture of convergent collision. We have mountains forming. This plate's moving down, this plate's moving up. They're colliding and energy is producing these mountains. Divergent boundaries separating. One's moving to this direction. One's moving that direction. And the separation, we have a divergent boundary right there. Transformings here. We have these. This is San Andreas Fault. One's moving this direction, one's moving this direction generally, and when they slip past each other, that's when you get our earthquakes. Okay, they're kind of stuck together, and when the pressure builds up and they slip past one another, that's when we have our big-time seismic activity. Here's a picture of the earthquake, during, a little bit after. You can see the damage done, and then you can also see the damage done here of those earthquakes. Seismograph, the ancient one on the left, that has the power of these earthquakes. And the one on the right is a seismograph, more current. It kind of reads the intensity of each shock coming through. Epicenter is where the earthquake happened on the surface. Obviously, the generation of the power is actually generated below, and that's called the focus. So the epicenter is the place on the surface is where it is. If you go straight down, you get to the focus, and that's where the actual center of an earthquake is. The Richter scale is what they use to measure the intensity. Obviously, the higher the number, the greater the intensity. The lower the number, the less intense the earthquake is. All right, that's chapter 2. Plate tectonics. We're moving around on plates. The plates come together. Convergent boundaries. They go away from each other. Divergent boundaries, or they slip past each other. That's transform boundaries. Those things are responsible for our seismic activity. We talked about continental drift. All the continents were together, and now they've separated over time. And we talk about the solar system. That's chapter 2. Be ready for a quiz tomorrow. Probably anything about what the Earth's made of. The biosphere and Pangea. What is Pangea? Those 3 questions might be something you need to pay attention to. See you guys tomorrow in class.